Hello and welcome to our channel again. So here I am Suraj with a new video of mine where I will discuss a demanding question on levi-civita, which is a tensor quantity. So we are not going deep into the levi-civita but directly onto the question. Maybe in my tensor analysis video you will find out the detailed explanation of the levi-civita when I will make it. So now our priority in this particular video is to solve this particular problem, demanding problem. So let's start the demanding problem on the Levi-Civita. So what does it tells that the question was asked that we have to prove down that Levi-Civita is when we rotate the Levi-Civita it is unchanged. It means if we rotate the Levi-Civita, it means when we rotate it, it will become unchanged. It means if we rotate the Levi-Civita, which is a tensor quantity, it will remains unchanged. So the symbol of the Levi-Civita is the epsilon naught. Here ijk represents its indices like 1, 2, or 3. And also it is a rank 3 tensor. Okay, maybe we'll discuss all this about in later videos. But now our focus is to prove down that Levi-Civita when we rotate remains unchanged. So now let's move towards the proof of this particular thing. So suppose that there is a Levi-Civita, we take epsilon naught ijk, okay, and we transformed it. So the transformation matrices can be written as we can write it as R, I, and M, R, J, N, and here we can write it R, K, N. Okay, so this is how we are going to represent our indices. So here is a mistake. We have to write out here not n because n is repeated here. We will write it for some other values. Let's say L. Let's say we'll write here L for our new I, M, and L. So this is our, it means we transform our this particular epsilon naught to the E, M, and L. So what now we can do is that we are going to just see something. Suppose that I put the value of I is equals to the 1, J equals to the 2, and K equals to the 3. What we'll get is that by putting out the respective values of those particular quantity, it will become that E1, 2, 3 is equals to, and also putting down here also the values of our things, which will get as R1, M, R, putting the value of J, which is 2, N, and R3, L. And here our another E, M, N, L. Okay, so this is our what become. It is R1M, R2N, and R3L. So if you remember some of the properties of the rotational matrices, then you will remember that we write the determinant of R into the determinant of R here and into the epsilon naught 1, 2, 3. We can write it just like this particular expression. It means this particular expression here, which I have written here, this, okay. So this particular expression can be written as the determinant of R, and here epsilon naught 1, 2, 3. But how we can write this particular expression as this? So maybe this is our not objectives. So this is like a property of the rotation matrices, including the this particular formula, this particular tensors, Levi-Civita. Okay, so this is our what equations become. So after writing this, what we can get is that the epsilon naught of 1, 2, 3 can be represented at the as the determinant of the R into the epsilon naught 1, 2, 3. And if you remember that another property of rotation matrices is that the determinant of the rotation matrices is equals to the 1. Okay, So the determinant of the matrix is rotational is equals to the 1. Now you can get that 1, 2, 3 is equals to the epsilon naught 1, 2, 3. It means it is remain unchanged when we do the rotation to our this particular levi Civita. So this is a very basic proof for rotate when we rotate the levi Civita. What we have done is that we have defined, suppose that we define this particular vector, which is the transformation of this particular vector, and if this particular tensor, sorry, and if you will transform, I just assumption made that 1, 2, 3 is equals to the ijk, putting out the value, and what we saw is that this particular expression is just same as the determinant of the r epsilon naught 1, 2, 3, and you know that the determinant of r is equals to the plus 1, and if determinant of r plus 1, this equations become this. It means we have to choose the right option, that yeah, when we do the rotation of our this particular matrices, no this particular levi Civita, it is just equals to, it means it do not change. So this is our very important and special property in the levi Civita. So this is a demanding question on the levi Civita to prove down that it is remain unchanged when we rotate it. So thank you for watching my video.